All right, welcome to the 7.2 instructional video for Math 20-1. In 7.2, we're going to talk about how to deal with absolute value functions and how to graph them, and really how to describe them as what we call piecewise functions. This chart or table, I guess, of information is in your textbook. It's not actually in your notes. We're going to compile it into your notes, although you can see the definitions of the absolute value function and piecewise function are on the side. Really good idea to put those into the notes. If nothing else, write them out helps them to define. The most important idea, though, I think about dealing with these absolute values is that y equals the absolute value of x, which I'm just going to highlight here, can be written as two separate functions. And that's going to be something that's pretty important throughout 7.2, is that in order for us to talk about an absolute value function, we actually have to split it always into two pieces, basically, which is why piecewise is the terminology we use. So if we have y equals the absolute value of x, what we can do is we can write it as y equals x, and this is really important, that this is equal to x if the condition is satisfied. And the condition in this case is that x would have to be greater than or equal to 0. And I'm going to show you this, or we can look at this on the graph, that the red line is y equals x, and the blue line here is y equals the absolute value of x. When x is greater than 0, the blue line and the red line are exactly the same. So if there is a positive inside an absolute value, the absolute value doesn't do anything, which you saw in 7.1. Like, just as a quick example, the absolute value of positive 8 is positive 8, but the absolute value of negative 8 is different. If we are taking the absolute value of a negative number, and that's this bottom piece in yellow, I know kind of the angle is a little bit off there, but what I've underlined in yellow there is the idea that if we have the absolute value of a negative number, then the absolute value operator, or that notation we write, just multiplies the negative number by a negative, which makes it a positive. And you can get lost in the language a little bit here, but the most important concept is the absolute value of a positive does nothing. The absolute value of a negative multiplies that negative by negative 1, which changes the sign to positive. Now, graphically, this red section is y equals x when x is a negative value, so negative 1 or negative 2 or so on. Y equals the absolute value of x is going to take those negative numbers and multiply them by negative 1. And we can see that really consistently when we look at graphs. So I just have Desmos open here on two functions we're going to look at within the notes. So my red line is y equals 2x minus 3. But if I were to throw an absolute value in front of that, really what it's doing is taking where the function is negative and basically reflecting it across the x-axis. So the blue graph is y equals the absolute value of 2x minus 3. The red graph, which we kind of lose a piece here, is y equals 2x minus 3. And so in order to deal with that, to talk about this weird V shape, we actually have to describe this as two separate functions. And we're going to do that in example 1. So keep watching.